A few years back, I had a close friend who passed away due to heart disease. It was crushing as I recollect my memories of him. If only he was able to detect his symptoms faster, he would have been alive with me today. We discovered that many individuals are incapable or unwilling to make their way to a hospital for a proper diagnosis, as they tend to play off their symptoms as being less serious than they actually are. To prevent further instances of excessive complacency, we decided to develop a tool that can lead people in the right direction. Our app is cost-effective and is available 24/7, unlike family doctors. In addition, we offer novel flexibility when it comes to user inputs, as it can include a diverse selection of symptoms. Simply said, our app takes in user symptoms, detects the most probable results, and returns clear, well-formatted disease possibilities.
To develop our novel backend algorithm, we utilized an extensive database containing first-hand accounts of the symptoms for 25 of the most common diagnosable diseases. Then, using Python's scikit-learn package, we trained a support vector machine with an incredible 97% accuracy. When the user opens up the website, they will be greeted with our sleek homepage design. Let's navigate to the catalog page. This page displays the diseases that our model is trained on, each with a brief summary. Let's move on to the Find Illness page. The search bar at top is where users should enter their symptoms. To simulate a user experience, I googled and summarized the major symptoms of gastroesophageal reflux disease and ran it through the model. Once I hit submit, the model returns the 5 most likely diseases associated with the input in descending order, along with their symptoms, risk factors description, treatment, and prevention. As expected, gastroesophageal reflux disease is by far the most likely. Our model is extremely robust. Inputs that are irrelevant to the training data will return an error. The same thing can be said for inputs that are too short for a meaningful prediction. Users can access the About page for more information about us, and the FAQ page for answers to important questions, such as best practices for input and interpreting model output.
Divided into 4 major sections, our app includes a front end, a back end, our disease model, and the connections between them. For our front end, we wanted to avoid creating our website with plain HTML, CSS, and JavaScript, as this strategy is tedious and outdated, so we decided to use a front-end JavaScript library called React.js, which allowed us to automatically update the website every time a variable changed in the JavaScript code, and also allowed us to easily reuse HTML code in various places in the website. For the backend, we wanted to use Flask, a Python-based backend framework which allows us to receive our user inputs from the front end and feed them into Sean's Python-based disease model. This model is what takes the user's input as a parameter and returns the likelihood of the top 5 possible diseases. Finally, we needed a way to connect the front end to the back end so that we could feed the user's input into the disease model, and the clear option for this was Socket.io, a library which allows for bidirectional communication between the client and the server, and has great support for both Flask and React.js.
Thank you for providing us with a platform on which we could share our app, IllnessIQ.